What is GIS? GIS is computer software that links geographic information, where things are, with descriptive information, what things are. Unlike a flat paper map, where what you see is what you get, a GIS can present many layers of different information. A digital map is not much more difficult to use than a paper map. As on the paper map, there are dots or points that represent features on the map, such as cities, lines that represent features such as roads, and small areas that represent features such as lakes. All this information, where the point is located, how long the road is, and even how many square miles a lake occupies, is stored as layers in the digital format on a computer. Think of this geographic data as layers of information underneath the computer screen. Each layer represents a particular theme or feature of the map. One theme could be made up of all the roads in an area. Another theme could represent all the lakes. Yet another could represent all the cities. These themes can be laid on top of one another, creating a stack of information about the same geographic area. Each layer can be turned off and on, as if you were peeling a layer off the stack or placing it back on. You control the amount of information about an area that you want to see at any time on any specific map. A Geographic Information System, GIS, is a framework for gathering, managing, and analyzing data. Rooted in the science of geography, GIS integrates many types of data. It analyzes spatial location and organizes layers of information into visualizations using maps and 3D scenes. With this unique capability, GIS reveals deeper insights into data, such as patterns, relationships, and situations, helping users to make smarter decisions. Hundreds of thousands of organizations in virtually every field are using GIS to make maps that identify problems, monitor changes, manage and respond to events, perform forecasting, set priorities, and understand trends based on spatial analysis to help decision-making processes. How GIS works. GIS technology applies geographic science with tools for understanding and collaboration. It helps people reach a common goal, to gain actionable intelligence from all types of data. Maps are the geographic container for the data layers and analytics you want to work with. GIS maps are easily shared and embedded in apps, and accessible by virtually everyone, everywhere. GIS integrates many different kinds of data layers using spatial location. Most data has a geographic component. GIS data includes imagery, features, and base maps linked to spreadsheets and tables. Spatial analysis lets you evaluate suitability and capability, estimate and predict, interpret and understand, and much more, leading new perspectives to your insight and decision-making. Apps provide focused user experiences for getting work done and bringing GIS to life for everyone. GIS apps work virtually everywhere, on your mobile phones, tablets, in web browsers, and on desktops. GIS has 5 components: hardware, software, data, processes, and users. The most widespread licensed software in the world is ESRI ArcGIS Pro for desktop. In the next module, you will also learn to work with open source GIS like QGIS and its app for fieldwork called QField. There are other open source GIS like GVGIS or GRASS. Besides this, there are internet-based services like ArcGIS Online, Carto, Google Maps, Here, OpenStreetMap, and so on. Probably the most important components of a GIS are data. The related geographic and tabular data can be collected in the company, in the field, or acquired from the person who implements the information system, as well as from third parties who already have it available. The GIS integrates spatial data with other data resources and can even use the most common database administrators to organize, maintain, and manage spatial data and all geographic information. GIS are done from geospatial data and geo-referenced information. They can be spatial data, descriptive data, and temporary data. Spatial data is the geographic location using a coordinate reference system, latitude, longitude, and altitude, or a geocode when data are referred to an administrative unit. Topology is a collection of rules that, coupled with a set of editing tools and techniques, enable the geodata to more accurately model geometric relationships. Spatial data allow defining and drawing spatial properties like direction, distance, shape, size, separation or patterns. Descriptive data give the information about what or how much a spatial data is. They are the thematic attributes of the spatial entities represented by points, lines, polygons or pixels, and they are usually associated in a database or spreadsheet. Data can also provide temporary information in order to represent changes on the spatial entities or attributes. For example, if a province is gaining or losing population from one year to another. For a GIS to be successful, it must operate according to a well-designed and structured plan and in accordance with accurate methodology of processes, which are the characteristic operating models and practices. One 5-steps process example for the analysis process in GIS could be: frame the question, explore and prepare data, choose analysis methods and tools, perform the analysis, examine and refine results. GIS is an individual task for the mapmaker, but GIS is based on teamwork. And also, GIS is social. Every day, millions of people are using GIS in government, industry and academia. Modern GIS is about participation, sharing and collaboration. GIS people have realized that to be successful, they need data from other sources beyond their immediate work groups. People quickly recognize the need for data sharing. OpenGIS and data sharing have gained traction quite rapidly across the GIS community and continues to be a critical aspect of GIS implementation today. With cloud computing and the mobile app revolution, the GIS community is expanding to include almost everyone on the planet.